Hello, can you hear me okay? Yeah, good. So my name is Pablo, although online you might know me more with the name Pablisco. And at the moment I work as a contractor with Novoda, obviously with a K. I have to do it with a K these days. I'm originally from Spain, but I've been here for 14 years. And yeah, probably too long. So, another thing that I do in my spare time is we basically creating a course about functional programming, but I'll talk about that a bit more towards the end of the talk. Cool. So for this talk, I created a demo app. I call it Reddit TV. I'm gonna publicize the content next week, so make sure you follow me on Twitter. I was gonna call it, because it's a mix of Reddit and YouTube, I was thinking of calling it RedTube, but somebody told me that's already taken. If you don't know what it is, don't search it on the Wi-Fi, because, yeah. Basically, it looks something like this, but we'll get back into that in a minute. So before that was LCE. So LCE stands for Loading, Content, and Error. It's a bit of a spoiler before about this slide, but yeah, so first, before going to LCE, I'm gonna tell you talk about a little bit about state machines. So in programming, sorry, in programming, almost everything is done with state machines, even if not declared as a state machine. Although we call them finite state machines, but however, for this talk, I'm just going to call them state machines for brevity. So what constitutes a state machine? There are a few properties of a state machine that we need to take into account. So one of them is that you have a closed set of states. So if it's 3, it's not 2, it's not 4, and definitely not 5. You only have one state at a time, ideally. And normally you have actions which go into transitions, so you go from one state to another. And as a bonus, ideally you don't want to have any roadblocks. So you don't want your code to not be able to move from one state to another. But that just as a bonus for UX and UI and to keep your users a bit happy. Cool. So LCE is kind of a state machine in a way. So let's have a look to see if it actually fills all the conditions to be a state machine. So we have 3 states. So loading, content, error. So you can check that. Normally you would have one state, but that depends on the implementation. So we'll skip that one for now. Now we have transitions. So when you start you loading, then you go into ready when the content is ready, and if it fails, it goes to error. And potentially we shouldn't have any roadblocks. So if there's an error, we also want to go back. And if the content is out of date, we want to be able to reload. So, sorry, 1 second. Now that we know what state machines, let's have a look at a general view of how state machines can help your code and make you more efficient. So one of the things is that it'll make you think. So if you have a state machine, or if you have to define a state machine, then you have to think about all the possibilities and all the options that you can have. We do love to go right into the code, but sometimes it's good to actually stop and go one step back and have a bigger look of a bigger picture of what you need to do, basically. It's good for separation of concerns. So it's good to have a separation of your business logic and your presentation. Potentially, you could actually reuse your business logic in different platforms. Although ideally, it's also quite good for testing and in general for many other reasons, basically. Then traceability. That's something quite interesting with, if you have a state machine, it means that you can log when you go from one state to another. So then when you have a bug, you can actually go back into go back into your code and see if you replicate all the states, how you get into that unstable state and how you got there. And hopefully, the fact that you're using state machine, it means that you know as likely to get into those conditions. So finally, consistency, determinism, and having an expectation of your code. So most apps and projects are actually a state machine. The other thing is that state machine is a composition of other smaller state machines, which permutates into very many different options that you can have. Actually, can you hear me without it? No? Okay, sorry. So the fact that you encoding the states means that similar to mutability, you're not going to get into a place that you don't expect like that. So, just to recap, it helps you think, have all your layers separate, helps with tracing, and also consistency and making sure that your code is deterministic. Now, I thought about calling it, and I might or might have not spent all Saturday thinking about a name for it. We'll leave that to your imagination. But yeah, you could call it TSTD, something like that. So let's dive into Reddit TV and how I use LCD. LCD, no, that's a TV. LCE, that's the one. So we have loading with the queue animation, the content, and the error. So that's the three states that we were talking about earlier. Now, luckily for us, Kotlin has zero classes, which are amazing, and you should use them all the time. Well, not all the time, but often. You can actually do this with Java. However, you need to use a lot more code, and it's not as safe because you don't have how is it called? The when thing. Exhaustive, that's the one. Thank you. Public participation, great. So, for anyone that doesn't know, just recap what CL classes are. CL classes allow you to have a close hierarchy of types, and it's kind of like a union type, sort of, or kind of sum type, which is a bit of functional jargon in there. And it means that at compile time, you know all the implementations that you can have. So, good. So let's start with it. So we have the main state because it's the main one, as the top one that we have. And we'll start with loading. In this case, we have it as a singleton because we're only going to have one in this instance. But in the future, we could change it to something else. Then we have also the content. And the content has the user, which, well, in this case, a data class. And the user will give you all the information that you need to show. Well, not all of it, but the information that you need to follow onto the content screen. And finally, we have the error, which is error, which is also a data class. And with that one, you can show the error message to the user, basically. For anybody that doesn't know, data classes are like the primitive Java beans with all the faff, and very useful. So, how are we going to make the connection in between the two layers that we have? Is that the right order? Yeah. So the setup I had on this project is, probably you've seen this often. You have app and you have core. App is a Android with Kotlin project module. Well, depends who you talk to with. And core is plain Kotlin basically. So, the good thing about having this separation is that then in the future, hopefully, if I get time, I'm going to try to do it with multi-platform, which will be quite interesting if they manage to fix coroutines on native. And also for other reasons. We do love layers. We like to make things into layers, and I only have two, so it's quite a small onion in this case, but it's good for testing and, as I said, separation of concerns and all these things. Now, scary graph. This is how it looks roughly. With obviously, I couldn't put all the code in here, otherwise you wouldn't be able to read it. So I could have done this with dependency injection like Dagger, although don't use Dagger in Kotlin, or something like a coin or a similar thing. However, the way I did it doesn't actually require any tooling, which is quite nice. So you don't have to add extra dependencies or extra work into it. So let's have a look at how the main module, not the module, a greater module, but the dependency module. I have to make it clear because there's two different concepts here. So the way I defined it is basically you define a dependency as an abstract function, and then the actual implementation, obviously not to do because that will crash, but the actual implementation will use that dependency and provide the things that we need in our actual application. Now, the actual implementation of this on the main module will look roughly something like this, although obviously that's not production code. I'm hoping that nobody shipped something with like that in code, right? Anybody? Good. Oh, there's always one. So now, if we go back to the modules, well, the Gradle modules, but yeah, to the schematics, you can see that also the actual implementations are inside of a module, and these ones are implemented in two different variants. Variants, that's the one. So let's have a look at how they're implemented. So the way the modules is implemented, it actually has it's an interface, but it has default properties, so properties that actually have values and an implementation. We'll see why this is done like this in a minute. Well, that minute is come earlier than that. So in the actual, in the release version, we just extend the modules. The modules already has everything that it needs, so we don't have to do anything. Then we have the debug one, and the debug is a little bit more complicated, so I'll try to go step by step. So internally, we have a queue of modules, which we can modify and add extra modules. If the queue is not empty, sorry, it will try to get the next module and then return it. If it's empty, it will just return the default implementation. And then have a little bit the spy. Oh, hang on. Yeah, so the spy, we're going to look at how we're implementing the spy in this case, and that's it. So in here we pass the actual implementation that we have on main, and by using delegation with by, we can keep all the implementation but only override the things that we want to mock. In this case, we want to provide our own fakes for when we create the main state channel using coroutines, but I'm not going to go too much into details of that. But hopefully, be able to see it next week when I manage to release the code in Twitter. So, also, yeah, I was thinking of calling it fake because we're faking, but in this case, because it's spine, I thought spy is probably a better name. Yeah. So if we go back to our how the project is defined, I'm going to explain why I did this separation and how this works. Basically, when Android or Gradle assembles your code, if you are on the release variant, it will take the sources from main and the sources from release, merge them together, and deploy. Whereas in debug, it will get the main and also the debug source code. So in this case, main doesn't have the app modules implementation, so in each case, it's going to pick up one or the other. The reason I did the implementation of app modules like this is because most of the time we actually live in the debug build. So you want to be able, you don't want to have to do too many changes in the release, because otherwise you're going to forget, you're going to get errors, and you have to go back and forth and then compile, and you don't want to recompile the whole project if you have a massive Android project, because, well, unless you want to go for a coffee, basically. So why bother? You might probably be asking yourselves, why bother doing all this? Well, for one, prototyping and debugging. Here's an example of how doing that, I was able to generate screens that actually take a fake state, which means that you can actually prototype rapidly, even if your server is not ready or the backend code, the backend for the app code is not ready. And also you can work in parallel, so yay, efficiency. And also for debugging, because then you can go into a state that might be hard to replicate, like there's an error with something that you don't know how, and that creates some funny thing on your UI. So it's quite useful for that. Also, instrumentation tests. Now, you don't need to do any mocking because you already have something that allows you to queue states. Then you can check in your test if you have what you expected. There's a bit of a tangent. Yeah, I should have warned you, I like tangents. This function is quite an interesting pattern that I like to use when I'm able to do instrumentation tests. It looks something like that. Yay, block of code. But basically, encourage you to actually always have checks for all the views. Because it's quite easy to just go, okay, I'm loading. And it's like, oh, the loading is shown. It's like, yeah, but did you check that everything else that shouldn't be shown is not shown? So it's quite a nice pattern, basically, for testing. And tangent over, I think. I need to point that way. Yeah. Now, how we consume this, all this on the client, which is not the client, the app module. So on the main activity, all we have to do is grab the main view model, which I'm not going to bore you with the details because it's basically just transforming a channel into live data. And then here we observe it with a render function. And this is where it comes quite handy. Now, not sure if you can see, but this means that when you render in the state, you're going to have 3 distinct cases. So you have the extensiveness of the when, which in this case you do one the other, or the other. There's a couple of things I said. I like tangents. There's a couple of nice patterns that you might be interested in or not. I'm going to talk about them either way. So the first one is show only. This is quite good. In the same way that I was talking about testing, where you have to make sure that all the views that are not visible should not be visible, or that shouldn't be visible are not visible. In this case, if you create, what this method is doing is basically taking 2 lists of views, and if the ones that match are visible, the ones that don't match are invisible. So in your no, we got a problem. No, we ran out of battery. Ah, what do we do? There we go. Hey, so it's manual. Okay, I have to say next. That's good. I can drink that. Definitely water. So the good thing on that one is that one of the things is that you can create a list of views that you have on your layout, and then you can say, oh, I want to show only this, and you make sure that that also hides all the views that you don't want to show. There is the problem with this is that you have to update. So if you add a new view, you have to remember you have to put it in the list, which is painful and also error bound. So there is a safer alternative that can be done with data binding and binding adapters, but probably leave that one for a different talk. So let's try to see. Oh, is it working now? Oh, it's working. The other one I was talking about is side effects. So this does nothing. It doesn't add any code to your deployed application, but it gives you semantics. So in here you're saying, I'm going to do a side effect here. It's also quite useful if you have a body expression with a when, because in here, inside of the side effect, if you're doing something that actually returns an object, Kotlin's going to get very confused because it's going to say, I can't return that because you're expecting a unit. So it's going to go, bananas. So it's quite useful for that as well. And yeah, so that's all good. It looked very simple. We have 3 states. It's quite smooth. But that's because I was loading one thing, the user. The problem comes, what do you do if you have data while you're loading? Yeah, that's the interesting bit, right? So what happens is that you get something like this. It's like, wow, now we have so many states. And it's complex to follow. The code is going to be complex as well. You're going to have to do all the different cases. It kind of works. Problem is, if you start adding new aspects to it, it might get a bit complicated. So you might be thinking, oh, sorry, yeah, this is how you do it. So it's quite a lot of code, and there's a lot of overlaps because you have videos on several of them, so it can get a little bit overwhelming, and it doesn't really scale that well. Although it can, depends on your situation, what you have in your project. Now, you might be thinking about doing something like this. And it works. However, the problem with this is that you end up with all these possible permutations. A lot of states, actually. So you get 8. This one we don't need, because it's never going to be not loading and not have a content and not have error. So that one doesn't exist. These 2 don't exist, because if you're loading, you probably shouldn't be showing an error, because if you're loading, that error is in the past, so you've moved on. And now what happens is that we end up with the same thing that we had before. That's all the same states that we had on the previous slide. But less safe, and you have to check whether it's one or the other. So you get very messy when you're actually trying to consume a state like that, because you have to do lots of checks. It's error bound, and it's got some complications. So, have we thought of any other solutions? What about decomposition? I'm not talking about Kotlin decomposition. Well, no, that's deconstructing. That's a different one. Anyway, the classic divide and conquer. So let's say that we do the top level and we ignore loading. And we have just a stable and error. We don't care about loading here. And then when we go lower, we have loading, content, and loading with content. What this does, it gives you 2 different groups of states. So if you do the math, actually it means you have 6, but instead of the 8. But this has several benefits. Sorry. All of these are potentially good, as long as you know what you're doing. In this case, because we have smaller concepts, it's easy to grasp, potentially, depending on how many levels you have. There's that old saying that every programming computer has another level of indirection. So, and then when we want to render it in your fragment or wherever you're loading all the views, you basically pass it on to another component. In my case, I was doing that on the adapter. So then you lead the adapter doing all the hard work. So, what are the benefits of doing this? Well, as I said, you have smaller concepts and smaller components. Always good to have small things because it's easy to understand and you don't want to overcomplicate things. You can test them in isolation if you need to. And now, because we are rendering in, the second level of the state machine in the adapter, we can actually support pagination a lot easier than in the other one. Now, some conclusions and thoughts, almost finished, so you can grab a drink in a minute and get it over with. So it's good to have determinism. You wanna be able to replicate what you're doing and be able to know what's going to happen. It's good to think before you code. We think, but sometimes you have to think more. Also, it's good to test, debug. Hopefully, it's not a surprise for anybody here that testing and debugging is a good thing. Although debugging is not such a good thing, but a necessity sometimes. And also, if you have something that's a big problem, try to break it down, divide and conquer, all that. And with that, I got some spam before we finish. So I was saying earlier, we're working on this course for doing functional programming with Kotlin, and we just released it. But there's more. We have a special offer for you today. Basically, with this code, take your cameras if you want. You can get 35% discount, and we have the course is basically a set of videos about functional programming with Kotlin. We don't go too deep into category theory. We basically go into the basics and fundamentals of functional programming, which is a lot less intimidating than going fully into functional programming. Also, is a good way to learn all the different techniques that we have in Kotlin. Wait, there's more. We're gonna have a giveaway soon, hopefully next week, for a free course. So don't forget to follow us on Functional Hub. And hopefully you can get a free course. Like, everybody likes free stuff, right? Oh yeah, one more thing before we go and get more drinks. We also do the course in person with smaller groups, not such a big group, hopefully. So come talk to, well, I say us, but it's only me here. Or you can talk to us on Twitter. Yeah, so thank you.